Hi. Assalamualaikum and very good afternoon. Hi, I'm Cikgu Hamima. Today, I want to share about graphing exponential function. Exponential functions are defined by two types of the base, which are base A of index form or base exponent E. So let's see the example here. A and B are the types of the base of A, where A must greater than 0 and A not equal to 1. So for the first example A, the base here is base 2. Example B is 1 over 3. We change to index form, it's become 3 to the power of negative 1. So for B, the base is 3. Let's look example C and D. C and D are the second types of exponential function with base exponent or base E. Next, sketch the graphs of the following functions, state their domain and range. Let's sketch our graph. By using properties, we can sketch the exponential function. But today, I want to show you another way how to sketch graph of exponential function, which is consider 4 steps. So, the first step is XY. XY means X or Y intercept. The second step is A. A is defined as asymptote. And then, exponential function have only horizontal asymptote. The third step, P. P is refer to the point. Point must in coordinates form, so X and Y coordinate. And the last one, S. S is refer to sketch and shape. To make it easier to recall all 4 steps, I apply mnemonics. The mnemonics is X, Y, X. Okay. Thanks and credit to Madam Raja Suzita, Madam Rosna and Madam Rosmawani because introduced this mnemonic. Okay. So the first one, we find out y-intercept. When y-intercept, the value of x equal to 0. So x equal to 0. When x equal to 0, we substitute into exponential function fx equal to 2 to the power of negative x is become f0 equal to 2 to the power of negative 0 is become 2 to the power of 0 is 1. Next, the second step, A. A is the asymptote. So, asymptote can find from, okay, on top, this is original function. At the back here is nothing. Nothing means plus 0. We rewrite like this because at the back here is referred to the asymptote. So in this case, our horizontal asymptote is y equal to 0. The third step, to find out the point. Okay, to get the point, we must know the sign of x and y coordinates. So how to get the sign of x and y? So refer to the function. In front of x here is negative sign. It means our x coordinate is negative. And then in front of y here or in front of fx is positive. So this is positive. here, fx here also y exists because from the Cartesian plane, vertical line is y or fx exists. Okay, next, the last one, we sketch and shape. So now, how to know the point? Is it in first, second, third or fourth quadrant? So we see Cartesian form or Cartesian plane, Q1. From the Cartesian plane, we have 4 quadrants. The first quadrant, this one, Q1. And then in this case, our x and y coordinates, we see 0 to the right is positive values of x. And then y coordinate 0 upwards, the value of y is positive sign. Let's see the next quadrant, quadrant 2. Quadrant 2, the coordinates of x, 0 to the left is negative. And then 0 upward, positive y. Next, quadrant 3. Quadrant 3, x 0 to the left, negative, y 0 and downward, negative sign. And last one, quadrant 4. Quadrant 4, x 0 to the right, positive, and then 0 downward, negative. So now, please go back to our third step. So third step here, our point negative, positive is mean in this case our point in second quadrant. Next label on the graph, y-intercept. When y-intercept x equal to 0, the value of y is 1. So let's put it here 1. Next, the second step, find out the horizontal asymptote y equal to 0. So y equal to 0 lies on x axis. So this is dotted line. I put it y equal to 0. And then the third step, find out the point. We know already our point in the second quadrant. So anywhere in the second quadrant, we plot, let's say here, x. So now we sketch our graph. And see horizontal asymptote here. When we sketch our graph only can approach y equal to 0 but not touch y equal to 0. Okay, so what are we doing? We join the point and then passes through y-intercept and extend, approaches y equal to 0. Okay. After that, state the domain and range of f. So, domain of f is referred to the values of x. So, from the graph, the minimum values of x approaches to negative infinity. And the maximum values of x, when we extend, our x approaches to positive infinity. And then, our range is referred to the values of y. From the graph, the minimum values of y approaches 0. So, minimum of y 0 but not touch y equal to 0 is mean open interval. And then, the maximum values of y approaches to positive infinity. So, this is positive infinity. Done for the first example. Okay, let's look example B. In this case, fx equal to 1 over 3 to the power of negative x minus 1. In this case, our base is fraction. So, we simplify in index form. It's become 3 to the power of negative 1 times the power of negative x minus 1. So, in this case, our base is 3. So, we simplify the indices by using the law of indices. We multiply negative 1 times negative x become positive x minus 1. So, this is our function fx. By using the mnemonics, the first step, we find out the y-intercept. when y-intercept the value of x equal to 0. So, when x equal to 0, we substitute into our function. So, f0 equal to 3 to the power of 0 minus 1. Any number to the power of 0 become 1. 1 minus 1 become 0. Next, the second one. We find out the asymptote. A is asymptote. So, in this case, our asymptote y equal to negative 1. The third step, we identify the sign of our point. So, our sign x and y, so we refer to this one. In front of x here, positive. In front of y also, positive. So, positive, positive. If positive x, positive y, is mean our point in first quadrant. Last one, we sketch. Okay, so now we see when y-intercept the values of x equal to 0, our f0 equal to 0 also is mean at origin. And then asymptote y equal to negative 1. Below the x-axis, y here, y equal to negative 1. And then I draw dotted line parallel with x-axis. So, sketch using ruler, draw dotted line. Okay, next we identify the point. The point lies in quadrant 1. So, this is quadrant 1. So, let's join the point. So, we join the point here. So, okay, this is our graph right now. Next, we state the domain of f and range of f. So, domain of x from the graph, the minimum values of x is become negative infinity, approaches negative infinity, and our maximum values of x approaches infinity. And then range. From our graph, the graph can't touch y equal to negative 1 because y equal to negative 1 is horizontal asymptote. So, the minimum values of y, negative 1, open interval, and then the maximum, positive infinity. So, this is the second example. Let's look C. Fx equal to exponential function base e. So, negative exponent to the power of 5x. In this case, at the back is nothing, is become plus 0. By using the mnemonic, the first step, find out the y-intercept. When y-intercept, the value of x equal to 0. So, f0 equal to negative exponent to the power of 5 times 0 plus 0. Okay, negative exponent to the power of 0 plus 0 is become negative 1. The second step, find out the asymptote. Okay, so in this case, at the back is the value of y or horizontal asymptote. So, horizontal asymptote y equal to 0. The third step, identify the sign, point. So, the sign of x here, in front of x positive, in front of y negative. So, positive x, negative y. So, positive x and negative y is mean this point in fourth quadrant. Let's sketch. So, we label here when y-intercept the values of x equal to 0. When x equal to 0, y equal to negative 1. Let's say this is negative 1. horizontal asymptote y equal to 0. It means our horizontal asymptote lies on x-axis. So this is our horizontal line. So put it here, y equal to 0. And then our point in quadrant 4. So let's say this is our quadrant 4. Label x there. Now we sketch our graph. So we join the point from here, go up, passes through y-intercept, and then approaches. Okay, next our graph approaches y equal to 0. So let's state the domain and range. Domain is the values of x. Minimum values of x is negative infinity. The maximum values of x approaches to infinity. And then the range. We see the range. The minimum values of y approaches negative infinity. And then our graph, we see the values of y approaches 0. So 0. So open interval. Let's look D. Fx equal to negative exponent to the power of negative x plus 3. So for the first step, find out the y-intercept. Y-intercept x equal to 0. So f0 equal to negative exponent to the power of negative 0 plus 3. It's become negative exponent 0 plus 3. Okay, negative exponent to the power of 0 is 1. Negative 1 plus 3 become 2. The second one, find out the asymptote. Asymptote. Our asymptote here, we see at the back of, okay, plus 3. So, y equal to 3. The third step, we identify the sign. So, point. Our sign here, in front of x negative, in front of y also negative. Negative, negative. So, negative, negative, negative x at the left hand side, negative 1 downward. So, it means our point in the third quadrant. So, let's sketch. Okay, last one, sketch. Okay, next, we label when x equal to 0. F0 is 2. Let's say this is 2. And then, asymptote y equal to 3. So, this is, let's say this is 3. Draw dotted line. Next, our point in quadrant 3. So, this is quadrant 3. So, let's say this is our point. Let's join the point. So, from this point, go up, intercept, y equal to 2, and sketch our graph. So, next, state the domain. Domain of f equal to the minimum values of x negative infinity, maximum positive infinity. Range of f equal to, okay, minimum of y negative infinity, maximum approaches 3. Okay, so this is the way by using mnemonic we can sketch exponential function more easier. Thank you everybody. So help me to subscribe, like and share. Thank you. Bye. See you next lesson. Bye.